In section 1.4, we're going to cover angles. An angle is the two-dimensional space created by the intersection of two rays, segments, or lines with the same endpoint. So if I have ray AB, I don't have an angle until I have a second ray or line segment. Now the angle is this two-dimensional space between the two rays. The vertex of this angle is a point, and it's going to be point A, capital A. The sides of this angle are going to be ray AB and ray AC. To name this angle, we first need to use angle notation. Many of you are used to writing an angle like this, but when I write an angle with pencil and paper, I need to distinguish this symbol from a less than symbol. So when I write an angle, I'm going to use a little arc mark. So to name this angle, I'm going to use three letters where the middle letter is my vertex. So this is going to be angle CAB. Or I could go the other way around, BAC. Notice that both times A is the middle letter. Now in this case, since there is only one angle associated with vertex A, I could call this angle A with just one letter. That's not always the case, but it's the case in this example. The protractor postulate gives me a way to measure angles. Just like the ruler postulate measures segments, I'm going to measure angles with a protractor. And the unit to measure an angle is degrees. Degrees are wedge-shaped units of measure, and a protractor keeps track of all of those wedge-shaped units. To use a protractor, I'm going to line up the vertex with this point right here. All protractors should have a point down here. Line up the vertex with that point. To find the measure of angle AOB, I need to find where ray OA and ray OB cross my protractor. OA crosses at either 149 or 31. Doesn't matter which I pick as long as I'm consistent when I go all the way around to ray OB. So I'm going to pick this top row. Ray OA is at 149 degrees, and ray OB is at 14 degrees. So to find the measure of angle AOB, I need to subtract those two numbers. Now the measure of AOB from here to here should be the same as from here to here. So I should be able to also take 14 minus 149. But that will give me a negative number, so I need to make sure that I take the absolute value. Just like measuring with the ruler postulate, I want to take the absolute value. So my measurement is always positive. So in this first one, 149 minus 14 is 135 degrees. And in the second one, I get negative 135 degrees. And when I take the absolute value, both times, the measure of angle AOB is 135 degrees. Now many of you don't measure your angles this way. You would take your protractor and line up that bottom line with the one ray. If you look, when you move the protractor so the bottom line lines up with one of the rays, this ray AO still crosses at 135, but this ray crosses at 0. So essentially I'm taking 135 minus 0. So I'm still doing this, I'm just subtracting 0. There are 4 kinds of angles. After I measure an angle, I can classify it. An acute angle has a measure that's less than 90 degrees. Think of acute little. A right angle has a measure equal to 90 degrees. The symbol for a right angle is a little box in the vertex of the angle. An obtuse angle has a measure more than 90 degrees. Obtuse is the bigger angle. And a straight angle is an angle whose measure is equal to 180 degrees. So the measure from here to here is 180 degrees. The angle addition postulate is much like the segment addition postulate. It gives me a way to add angles. So if P is in the interior of angle RST, the interior is between these sides, so I'm going to put point P right here. And if I connect S to P and turn that into a ray, I've created 2 new angles. And if I add 2 angles, the result is equal to an angle. So in this diagram, I could say angle RSP plus angle PST equals, well, if I take RSP plus PST, for an answer I get angle RST. Small angle plus small angle gives me big angle. If I measured these angles, I can figure out the measure of each one of these angles by just plugging in the numbers. So the measure of angle RSP plus the measure of angle PST equals the measure of angle RST. And if I know 2 of these, I can figure out the third just by doing math or algebra. And the last definition is an angle bisector. To bisect something means cut into 2 equal parts. So if I divide an angle, I'm going to end up with 2 congruent angles. If ray BD bisects angle ABC, then let's first draw in ray BD. I'm going to put D in the interior, and I'm going to connect B to D. And I end up with a picture that looks a lot like the angle addition postulate, but in this case, BD is a very specific ray. It's a ray that bisects angle ABC. So I don't just have any 2 angles, I have 2 angles that are congruent to each other. So angle ABD is congruent to angle DBC. If 2 angles are congruent to each other, then their measures are equal to each other. So the angle bisector is like a very specific angle addition postulate. I could still say that ABD plus DBC equals ABD or ABC, but more specifically, I also have these 2 angles congruent to each other. Now the symbol for congruent angles in a picture is arcs. So if I want to say that ABD is congruent to DBC, I'm going to put 1 arc in each one of those angles.